In section 6, we look at families of functions. We have a parent function, and then we have all of its kids that we can talk about. That's why we're saying families of functions. The parent function is the original function, like y equals x squared, y equals x to the third, y equals the square root of x, y equals sine x. Those are all parent functions. Nothing has been done to them. Once we start doing transformations on them, then we start getting transformed functions. And all of those transformed functions fall under the family of the parent function, whichever parent function that happens to be. We'll be dealing with parent functions. Y equals the absolute value of x is coming up first. We'll be dealing with parent functions a lot in this class as the year progresses. So it's best to learn them well now. For vertical translations, the word vertical means up and down. If I want to translate, meaning move, a function up or down, I'm going to move it by adding k outside. And I'm going to use function notation to write this. I'm going to have my function f of x, and I'm going to add k to it. That's moving up. If I want to move down, then I'm going to have my original function f of x, whatever it is. If I want to move that whole function down a certain amount of units, k, then I'm going to subtract k. Okay? For horizontal translations, moving the function a specific amount left or right, the whole thing moves. The function itself, the shape of the function does not change. You're just translating left or right. If I have my original function f of x, then I'm going to have to subtract h from x inside the parentheses, x minus h, if I want it to go to the right. If I want this thing to go to the left, then that means that my h would need to be negative. Okay? F of x minus, because that minus sign is supposed to be there, negative h. Which we know simplifies to f of x plus h, because we have a minus minus, and that turns into plus. Okay? So that's the trickiest part about these transformations. If I have x plus some number inside parentheses for my parent function, or under the square root, or inside the absolute value, that's going to move it left. Because what I actually have is x minus a negative number. You should have seen that on your packets. Nod your head if you did. Okay. Thanks for nodding your head. Vertical stretches and compressions. On the packet, I said call it whatever you want. Call it skinny and fat. When you change that parabola, the original parabola looked like this, and then you dilated it, and it wound up looking like that. It looked like it got skinnier. That is a vertical stretch. If you had your original parabola like this, and you dilated it, and it wound up looking like that, some of us may have called that it looked like it got fatter. That is a vertical compression. Okay? Think of this in terms of a rubber band. If I have a parabola on a giant rubber band and I take that parabola and I stretch the rubber band vertically, what happens to the shape of the parabola? What's it look like happens as I stretch the rubber band? What? It gets narrower, yeah. It looks like it's been stretched, okay? So picture this parabola on a rubber band and I stretch it. It looks like the parabola becomes skinnier. It gets narrower, kind of, okay? That is why I'm calling that a vertical stretch. For vertical stretches, a will be greater than 1. So I'll have a times whatever my function was that I was looking at. For a vertical compression, that's when the parabola will get fat. So if I were to somehow have a rubber band that I could then compress, I could squish it down, it's getting squeezed, the parabola will have no choice but to become fatter. Okay? That's a compression. Like if you put your head in a vise and you just started cranking the vise, what would happen to your head probably? It'd start to squeeze. And then it would start to bulge. And then eventually it would pop, but while it was bulging, that's what we're talking about here. This is going to bulge out some. Okay? If you need to throw up, there's a garbage can over there. Vertical compression happens when A is between 0 and 1. Notice I'm not talking about negative numbers here. If the value of A itself, the magnitude of A, is between 0 and 1, then you're looking at a fraction that's less than 1. Okay? If that's what you have, then you're going to be dealing with a compression. The parabola will look fatter. It will be A times f of x still, but that value of A is going to be between 0 and 1. Okay, for reflections. We handled reflections in that packet for the x-axis. We can flip the parabola over the x-axis by making A negative. So I can write negative f of x. Technically there A would be what? Negative 1. Good. If I also dilate it, then A would be some other number besides 1, but it would still be negative. If I want to reflect in the y-axis, it's hard to do on that packet, and that's why we didn't do it, because the parabola is symmetric about the y-axis as it is. But if I want to reflect about the y-axis, then instead of a negative sign out front, I'll have a negative sign inside, f of negative x. And all this means is I substitute negative x into my original equation everywhere that I see x. And that will reflect the entire function about the y-axis. We'll get into this more as this section goes on and as we get into different parent functions. It's kind of tough to talk about with parabolas. Okay, so let's take a look at what we would consider to be a very easy function, but is actually kind of a hard function to talk about when we're dealing with transformations. A linear function. How are the functions y equals x and y equals x minus 2 related? They're both the parent function y equals x. So I could say parent function is y equals x. How are they different? So what happened with that minus 2? What did that do to my parent function y equals x? And k does what? Translation which way? Down 2 units, right? It's still the same function, it just got moved down 2 units. And of course, you know how to graph y equals x minus 2. You go to the y-intercept, which is negative 2, and then you graph your slope of 1 over 1, and that's how you come up with the graph, right? Well, the parent function y equals x looks like that. It's supposed to go through the origin there. Looks like that. The translated function looks like this. It has the same slope, it's just that now it's going through negative 2 on the y-axis. The whole thing got shifted down 2 units. Okay? It is the same function. One is translated, though. What is the equation for the graph of y equals x squared minus 1 if I want to translate it up 5 units? We can think about this graphically. The graph of y equals x squared would be the parent function, but y equals x squared minus 1 would shift it down 1 unit, okay? And y equals x squared is a, what kind of graph? What, is it a line? Is it a smiley face? What is it? It's a parabola. So here's negative 1. Here's my parabola for y equals x squared. Not the greatest parabola I've ever drawn in my entire life, and that disappoints me. So here's the parabola. I want to shift it up 5 units. What will the equation be if I want this thing shifted up 5 units from where it's at right now? y equals x squared plus 4 is correct. Okay? We want that thing to be going through positive 4 because that's 5 units up from negative 1. So now my parabola will be up here. Okay? That's the idea. How did I do that algebraically is the question. I could write it as this thing here being f of x. If that's f of x, then my new function translated up 5 units will be f of x, what? Plus 5. Okay? If this is my original function here, and I want to translate it up 5 units, I have to add 5 units to the original function. So now what I can do is I can substitute in what my f of x is. I have y equals the x squared minus 1, and then the plus 5 on the outside. Then simplify it down. Y equals x squared plus 4. There's your answer. So you can do this graphically. That's how you do it algebraically, and that's what you need to know. Let g of x be the reflection of f of x equals 3x plus 3 in the y-axis. What is the function rule for g of x? I want to reflect in the y-axis. How do I reflect something in the y-axis? I need f of negative x. Look back at that page that's so important that you laminated and have it glued all over the place in your house and in your locker. Right? Once your tattoo heals, you can look at that too. Just keep applying lotion. That's what I need. So I'm going to take my function, which is right here, f of x, and I'm going to turn it into f of negative x. F of negative x equals, what that means is substitute negative x in everywhere that you see x. So I will write 3, parentheses, negative x plus 3. Then simplify it down. So that becomes f of negative x equals negative 3x plus 3. And that's your answer. That has now been reflected in the y-axis. Do you believe me? Yawns and blank stares. So nobody believes me. I'm going to plot a new function, and it's going to be the function I just had, which was 3x plus 3. There's your graph. If I reflect this thing in the y-axis, then it's as if the y-axis itself is a mirror. So every point that looks into the mirror will be reflected in the mirror. So this ordered pair will be reflected over to here. This ordered pair will reflect over to here. This one will stay put. It's like having your nose smashed against the mirror. Okay? The reflection will have your nose smashed against the mirror on the other side. Agreed? Yes. This point will reflect over here with my new function once I've done this reflection. My reflected equation was y equals, or f of x equals, what? Negative 3x plus 3. Did I get a reflected equation? Does it look like maybe the line y equals, or sorry, the y-axis could be my mirror that reflects that equation? And the y-axis? Yes, it does, because it is. Because the math here works. The algebra works. You just got to believe it. Not like Santa Claus. Okay? Let h of x be the reflection of f of x equals, so let me rewrite this. I have f of negative x equals negative 3x plus 3. This says let g of x be that new function. So instead of writing f of negative x, my answer is actually going to be g of x equals negative 3x plus 3. There's your answer. So let h of x be the reflection of f of x equals 3x plus 3, but this time in the x-axis. What is the function rule for h of x now? So how do I reflect in the x-axis first of all? Negative f of x. So what I'm going to do is I'm going to write h of x is going to be the reflection of f of x in the x-axis. And we just said that in order for me to reflect in the x-axis, I need negative f of x. So I'm going to write h of x equals negative f of x. That sets up what I need to do. So now I'm going to substitute f of x in. I get h of x equals that negative sign out front, substitute in my function x, f of x. So 3x plus 3. Then simplify it down. H of x equals negative 3x minus 3. There's your answer. Do you believe that that is the reflection in the x-axis of the original function? More blank stares? Here we go. Let me get rid of the second guy here because that was our reflection in the y-axis. I want negative 3x minus 3. Does that look like we could have reflected the original line in the x-axis? Yeah, it does. X-axis would be like the surface of a lake that has no ripples on it at all. Above would be the sky, below would be the reflection of the sky in the lake. Make sense? We could draw a little bird, maybe a sunshine with a smiley face on it. But that's what we're doing here. All right, so that was like easy stuff. Let's make it more complicated, because that's what we do in Algebra 2. The graph of g of x is the graph of f of x equals 4x. So this is the equation that they're giving me. And then compressed vertically. What does compressed vertically by the factor of 1/2 mean? What am I doing? I'm making it wider. That would be what kind of transformation? That's a dilation. So this thing is going to look fatter than normal, compressed vertically by the factor 1/2, and then reflected in the y-axis. What is the resulting function for g of x? So let's put this together in terms of our transformations first, and then we'll substitute in the original function and simplify it down to get our answer. So the graph of g of x is, so equals, the graph of f of x. I know it's f of x equals 4x, but I'm leaving that alone for now. I want to compress f of x vertically by the factor 1/2. How will I write that? 1/2 of f of x. Doesn't that compress my function f of x vertically by a factor of 1/2? I think so. Then I want to reflect it in the y-axis. How do I reflect in the y-axis? I need negative x in f of x. So instead of f of x, I'm going to actually have f of negative x. That's the thing that tells me what to do to my original function so that I get my answer for g of x. So I'll have g of x equals the 1/2 out front times f of negative x. So that will be 4 parentheses negative x. You're substituting negative x in everywhere that you see x. Then simplify it down. That's the hard part. After that, like this right here, that's the hard part. After that, it's easy. G of x equals, I have 1/2 times 4 times negative x. What do I get? So inside the parentheses first, fine. 4 times negative x becomes negative 4x, and then times the 1/2, negative 2x. By the way, since it's all multiplication, it all happens at the same time. It doesn't matter what order you do it in. Okay? G of x equals negative 2x is the answer. Let's check that on Sketchpad. Original function here is 4x. So, plot new function, 4x. All right, there's my graph. Now, we said that this is going to be reflected in the y-axis. So if that's the case, then my line would look like that, right? Something like that. But I also compressed it. So that's going to make it look squished. So instead of a line that's like this, if I squish this, what's it going to look like? Huh? Picture a rubber band. I have the rubber band stretched. I draw this line in there, and then I slowly let go of the rubber band. What will that line do? It's going to flatten out. That's right. Okay. Always go back to the rubber band when we're talking about stretches and compressions. Okay. So let's take a look now and see what happens. We have f of x equals 4x. I know it says h of x there. Don't worry about that. So I need to draw a new graph in here. And the result that we got was negative 2x. Okay, did it reflect in the y-axis? Yes. Did it dilate? Did it get flatter as we thought it would? Yeah. So it's hard to really picture these things when we're dealing with lines. When we get into parabolas and stuff, it'll become much more obvious. But that is what's going on here. You have dilations going on. Things are getting fatter. They're getting flatter for lines. They're getting steeper for lines. Or they're getting fatter or skinnier for parabolas, and so on. Okay? It all goes back to the stretching and compressing of a rubber band. So for this one, we have a different approach. We were given an original function, and then we were told to do some transformations on it. This type of problem is giving us the original function and the new function, and we have to try to figure out what transformations made that new function happen. Okay? So what I'm going to do is, since this is the original and this is the new, I'm going to write g of x equals, and then I'm going to write what I did to f of x to make g of x happen. So what did I do to f of x? I multiplied by, I turned 2x squared into 6x squared. So I multiplied by 3. So that means I have 3 f of x. 3 f of x gives me 3 times 2x squared, which gives me 6x squared. But that doesn't give me all of g of x. So how do I need to adjust this here? The minus 1. G of x now is written in terms of f of x. How did I get g of x? I multiplied f of x by 3, and then I subtracted 1 from it. The result is 6x squared minus 1. So what is that 3 out front? This is a dilation with a factor of, dilation by a factor of 3. So that would be a stretch. And then what is this? Translated, which way? Down. How far? 1 unit. Okay? So if I'm listing transformations that are done, that's what I would do. What transformations change the graph of f of x to the graph of g of x? This is how to write it out algebraically. So in words then, we have dilate, or stretch, I guess, vertically by a factor of what? 3. Then what? Then translate. Which way? Down. 12. 1. Now instead of stretch, I could write dilate. Instead of stretch vertically, dilate vertically by a factor of 3. Then translate down 1. That would be fine. All right, for the first one, what do we need to do? G of x is going to be our new function, and it's going to be some sort of change that we did to f of x. What are we doing to f of x? Vertically stretched by a factor of 2, so to do that, I'm going to have g of x equals 2 times f of x. And then what am I doing to it? Translating down 3 units. So to do that, I will subtract 3 out front, or behind it. What is the function rule then? Now what do we do? G of x equals 2 times f of x, which is just x, minus 3. Anything left to do there? No, that's it. That's the answer. We're done. What transformations change the graph of f of x equals x squared to the graph of g of x equals x plus 4 squared minus 2? Let's do this algebraically first, and then we'll put it into words. So I'm going to have g of x equals, what am I doing to f of x? I'm adding 4 to x inside the function. So I'll write f of x plus 4. Is it squared? No, it's not. In the final equation it is. The function itself is this. Okay? What are we doing to the function itself? We're doing this. And then we're going to subtract 2 outside. This thing here is not squared. This is the notation that leads me to the answer. Okay? It's not squared because what I'm doing is I'm writing g of x in terms of f of x. F of x is not f of x anymore. It's f of x plus 4. Okay? The function itself tells me to square x plus 4. This is just going to be f of x plus 4. I'm changing x to x plus 4. That's why I don't write the square. In the end, though, when I substitute x plus 4 in here, this will become x plus 4, and then it tells me to square it. And then I'm telling myself to subtract 2. And that's when I get that. Okay? In words, what did I do? Translate. Which way? Left or right? I see a plus 4, so that's going left. Translate left. 4. And translate down 2. Whatever that original function looked like, which in this case would be a parabola. I translated it left 4 and then down 2.